Hello, this video is going to help with section 1-1 of Algebra 2, and it's called Patterns and Expressions. Well, I guess it could be in a different class than just Algebra 2, but that's what this one is mostly for. So, as I'm going through this, you're welcome to pause the video and try some of the problems and add them to your notebooks or however you want to do that. But there's some basic definitions that you should know, but maybe you forgot. So first definition is, what is a constant? Well, a constant is just a quantity whose values don't change. So it's a quantity or quantities whose values don't change. So in math, that's typically a number. So a lot of constants are a number, right? They don't change. It's a number. Three isn't going to change into four, or it's a constant. It's always going to be that number in like a math problem. That number stays the same. What can change is that variable. And a variable, the values just can change. And remember, it's like a letter or a number. Oops, a letter or a symbol. That represent a number. So it's a letter or symbol that represents a number. So we're going to use constants and variables in the middle of what we call an expression. Or we can use them in equations too. Remember, an expression is just a math problem or a math phrase, is kind of what this book kind of goes with, is what it calls it, is a phrase with no equal sign. So when we're doing all these expression work, we don't have an equal sign in our problem. If we add that equal sign, it's called an equation. So we do a lot of expression work, and then we have the equation work as well. So with the patterns, we're going to look at some patterns that are like shapes, and you basically are describing that pattern. So let me show you one real quick out of the book. So let's look at just this first one here. Oh, that's a little blurry. There we go. All right, so, and then this needs to stay still so it stops moving. All right, it looks like a video like on your phone. Whoop, whoop. So we have a little box, and then it goes two boxes down in a diagonal, then three, then four. What would be the next thing? Well, it would be five, right? So you're adding a box each time to that pattern. So you would describe that some way with words and or draw them. So there's lots of different patterns that you can look at and kind of follow and come up with the next pattern. But when it gets a little more challenging is when we look at the pattern in the terms of just numbers. So for example, what if my pattern goes 2, 5, 11. So 2, 5, 8, 11. So here's my pattern, or it's a sequence, or whatever they want to call it at this time. What would be the next number in my pattern? So it goes 2, 5, 8, 11. So it goes 2 to 5, right, is how many numbers? 3. And then from 5 to 8 is 3 more. 8 to 11 is 3 more. So all we're really doing is adding 3. So we can say, well, the next number would be 14, add 3 more, and we'd get 17, and you could so forth follow that pattern. So we also could put those in a column, and they kind of like the input column and the output column, but they have a little process in here. So this is kind of how the book likes to do it. Oops. So they like to do it, okay, here's our input. And that's going to be 1, 2, 3, and then maybe 4, and then I'm going to say n. And then this is their process column. And then they have the output. Sometimes it's like X, Y. It's the same thing. Writing them this way is the same as this. How this is like we have our inputs 1, 2, 3, 4. Here we would call this term 1, term 2, term 3, term 4. But it's the same idea. You can say, okay, term 5 would be 14, term 6 would be. So it's the same idea with the input is still 1, 2, 3, 4. What if the process went like 1 times 4, 2 times 4, 3 times 4? What would be the next one? What would be the pattern if that's our process that we're doing? Timesing by 4. The next one would be 4 times 4. And what if it was a letter, a variable in that input? It would then be n times 4. And then you could write your outputs from that process, which would just be 4, 8, 12, 16, and then I'd like to write this as 4n instead of n4. That's just the way we usually write it, is the letter first, the number first. So here we go. This is our input output, and we have the expression that represents this pattern as well. If we were thinking of this in terms of a sequence, you would actually only get that output, and they don't give you the input or the process. So you would just see 4, 8, 12, 16, and not really the 4n. Maybe you have to come up with that, but that's another thing you'll have to see. So it looks like when we're looking at patterns, like this one, we're adding 3 each time. This one, we're going up by 4 each time. When we're going up by a number, we're actually multiplying by that number. So a lot of people want to write the pattern or the expression as add something when it's not, it's multiplying. Think of how multiplication tables go. Like if we look at the 2's, it goes 2, 4, 6, 8, 10. You're adding 2 each time, but it's the multiples of 2. So in order for the pattern to work, you're going to times by what you're going up on the expression, and then you might have to add or subtract. So let's give some examples of where you might have to add or subtract on your pattern. So what if I could put this in the input-output format. Oops. Or I could just say, what if it goes 0, 1, 2, 3. Oh, this one's a little bit easier. That's okay. What if I go 0, 1, 2, 3? Now I could see this written this way. 1, 2, 3, 4 with a line and see the 0, 1, 2, 3. And then maybe you come up with the next, that 5th term, and maybe you come up with that expression for that nth term. So you could see it both ways, and I want to show you both ways because you've learned both of these somewhere along the line, and I want to make sure you truly understand how the expression goes. So look at this, 0 to 1, 1 to 2, 2 to 3. What are we going up by each time? By 1. So we're timesing the n on the expression by 1. N times 1. But if we look, n times 1 or 1 times 1 doesn't give me 0. 2 times 1 doesn't give me 1. I'm off. And how many am I off by? I'm off by 1 down. So that's where I would look at the subtraction. I need to subtract 1 from that. So I'm going up by 1s, so you're going to times by the 1. But I'm going down 1 from that, so I'm just subtracting 1. So this is what subtraction on 1 goes by, you're just subtracting it a 1 each time on this one. All right, so let's look at one that has kind of a mixture. All right, so what if our pattern went, I guess I'll write it in the column. 1, 2, 3, 4. You can't see what I'm doing. 1, 2, 3, 4, 2, -3, -8, -13, Here's my pattern. Again, you could have just seen these in a sequence, the numbers over here on the output side. So what is our expression, our nth kind of idea, right? What is the nth one? What are we doing? Well, let's look. What are we doing as we go down? And make sure you go by 1, 2, 3, 4. This whole section does. You can't skip numbers and then be able to follow a pattern. It doesn't work that way. Okay, so 2 to negative 3, excuse my odds. How much are we going down by each time? So we're going down, it looks like negative 5, right? So 3 to 8 is another negative 5. 8 to 13 again is another negative 5. So we're going down by negative 5s, or they're multiples of negative 5. So I know when I go to write this nth term, I have to take negative 5 times my n. Now, I need to look at that add or subtraction idea. Well, if I look at just the first one, 1 times negative 5 does not get me to 2. 1 times negative 5 is negative 5. So how many can I add to get all the way back to a positive 2? It would be 7. Let's see if this works for the next one. 2 times negative 5 is negative 10 plus 7 does give me negative 3. 3 times negative 5 is negative 15 plus 7 does give me negative 8. So this pattern works. Check it with more than one number. So again, you look at what you're going down by each time, which on this one was negative 5. And then you look at, because it was negative 5 each time, and then from there you have to look at how far off you are. So it kind of takes some thought process to figure out, well, I'm got to add a 7. It's a huge number. You could also look at these in a graph form. So let's see, what if I had a graph? It would look like these are just positive. I'll do an easier one. What if the graph was, oh, that one's a little hard. 1, 2, 3, 4, 5. That's right, I'm just going to do this one anyway. All right, so what if I had at 1, I was at 3. 1, 2, 3. 1, 3 is my first dot. I'm doing it, and I'm not doing it very fast, I might add. 2 will be at 5. And 3 is going to be at 7. And 4 would be up at 9. So you can see that these form a straight line when they are in a sequence form or from input output. They almost always form a straight line because they're linear. That's why we can write an equation linear. Unless you throw in an n squared, then it doesn't become linear. It's a U shape, or a absolute value, then it's a V shape. So for the majority, if it's just an n or an x, then we do have that straight line. Okay, let's look at this. We can take the graph and go to our expression. Let's look. 1 took us to 1, 2, 3, right? So 3 is our output on our first one. The next output would be 5. The next output would be 7. And the last output here would be 9. So our pattern goes 3, 5, 7, 9. How many are we going up by each time when we are in this pattern? So we're going up by 2, right? You can see that pattern here. We're going up by 2s. And so we know we have to times the n by 2 because that's what we're multiples of 2. But to get from 1 up to 3, so we're going to go from 1 to 3, right? So you put in a 1 input and we want to get out of 3. Well, 1 times 2 is definitely not going to get us out of 3. But if I add 1 to it, I can say, okay, put in a 1. 1 times 2 is 2. Plus 1 would get me that 3. If I put in a 2, 2 times 2 is 4, plus 1 would get me that 5, and so forth. So here is the expression from our pattern in the graph. And a lot of the homework's a little easier. I wanted to make sure we kind of went over this in detail with just to remind you how to write an expression from a pattern and think of it in terms of multiples. So hopefully you found this helpful.